All right, welcome. Today we're going to jump right into the world of Python's machine learning libraries. The big idea here is to really clear up the confusion between the two heavyweights, Scikit-Learn and Tensorflow, so you can figure out which one is the perfect tool for whatever you're building.
Okay, let's just dive right in. You hear these names all the time: Scikit-Learn, TensorFlow, Pytorch, and with all these powerhouse options, it's totally understandable to feel a bit lost. So which one should you be using? Let's break it down and find out. So here's how we're going to tackle this. First, we'll get that big picture view of the machine learning landscape. Then, we'll zoom right in on how these machines actually learn. And then, it's time for the main event, a real head-to-head comparison to help you pick your winner.
Okay, first things first. Before we can even start comparing tools, we've got to be on the same page about what we're even talking about. So what is machine learning, really?
The really crucial thing to get here is that it's a total flip in how we think about programming. Instead of you or me writing out endless rules, if this happens, do that, we just hand the computer a whole mountain of data and say, here, you figure out the patterns. It's all about learning from experience, not from a strict set of instructions.
So, okay, how does this learning thing actually work? Well, there are a couple of ways, but it really boils down to two main approaches, and they are very, very different from each other.
And this slide just nails the difference. Over on the left, you've got supervised learning. Think of this like studying for a test when you have the answer key. You show it data that's already labeled, like this is a picture of a cat, this is a dog. It learns by checking its work against the right answers. But on the right, you have unsupervised learning. This is more like getting a giant messy box of Legos dumped on the floor and being told to sort them. There are no labels, no right answers. The whole point is for the machine to find the hidden structures all by itself. Like grouping customers together based on what they buy. And this distinction between labeled and unlabeled data leads us right to this huge fork in the road in the ML world. It's a split that pretty much decides which tool you're going to use. We're talking about traditional machine learning versus deep learning. So here's a super simple way to think about it. Traditional ML, that's Scikit-Learn's home turf, is your go-to for analyzing nice, neat, structured data. Think spreadsheets, right? Rows and columns. You'd use it to predict house prices from a list of features. Deep learning, on the other hand, that's where TensorFlow and Pytorch live, is built for the messy stuff, the unstructured data. We're talking images, audio clips, blocks of text. It's for understanding what's in a photo, not just what a number in a cell means. Okay, so keeping that big divide in mind, let's kick things off with the absolute master of traditional machine learning, Scikit-Learn. The whole idea behind Scikit-Learn is to be powerful, but also super easy to get started with. That simple, consistent API is a really big deal. It means you can try out a bunch of different algorithms, and swapping one for another is often literally just changing one line of code. It's awesome. And it comes packed with all the essential tools you need, like for hyperparameter tuning, which, is just a fancy term for fiddling with the settings to get the best performance. Oh, and it works seamlessly with the other tools you're probably already using, like NumPy and Pandas. This is really where it shines. For all those classic data science tasks, figuring out if an email is spam, grouping your customers, predicting prices, Scikit-Learn is just so efficient. Seriously, if your data can live in a spreadsheet, Scikit-Learn should probably be your first stop.
And this right here is a perfect example of what makes Scikit-Learn so valuable. It gives you these robust, ready-to-go implementations of foundational algorithms, like logistic regression. That's a classic for any problem that has a yes-no answer, like, is this transaction fraudulent? You don't have to build it from the ground up. You just import it and use it. It's a huge time saver.
Okay, but what happens when your data is messy? What if it doesn't fit into neat rows and columns? I'm talking about images, sound files, huge chunks of text. For that kind of problem, we need to bring in the big guns, the deep learning specialists. This quote just hits the nail on the head. These aren't just libraries with a few tools. They are full-on frameworks. They're like the entire construction site, not just the toolbox. They are built from the ground up to design, train, and scale these incredibly complex neural networks that can tackle things way beyond what traditional ML can handle. So this is where you have to make a choice, and it's a really important one. On one side, you have TensorFlow. It's backed by Google, and it is an absolute beast when it comes to deployment. It's got this massive ecosystem for what we call ML ops. Basically, all the stuff you need to take a model out of your notebook and put it into the real world, at scale. Then you have Pytorch. It's famous for being flexible, for feeling more natural to a Python developer. That's why researchers love it. It's just faster for trying out new, crazy ideas and debugging them.
And listen, you really can't talk about TensorFlow today without talking about Keras. Keras is its official high-level API, and it is a complete game changer. Think of it like a really nice, user-friendly dashboard for a super powerful engine. It makes building these complex neural networks way, way easier than it used to be.
All right, so we've covered a lot of ground. We've got Scikit-Learn for our traditional tasks and TensorFlow or Pytorch for deep learning. So, the million-dollar question, how do you pick the right one for your job?
This table is awesome because it lays it all out so clearly. It really just comes down to this. Scikit-Learn is higher level, it's more plug-and-play for standard ML. TensorFlow gives you much more granular control, which you need for deep learning, and it's built to handle absolutely massive amounts of data and be deployed in serious production environments. And this right here, this is the final takeaway. It's the cheat sheet. It's not about which one is the best in some abstract sense. It's always, always about the right tool for the job. You've got structured, tabular data. Don't overthink it. Start with Scikit-Learn. You're doing cutting-edge research, trying to invent a new kind of neural network. Pytorch is probably your best bet. And if you're building a deep learning application that needs to serve millions of users reliably, well, that's what TensorFlow was built for.
Which, leaves us with a really interesting question to chew on. As AI keeps getting more and more powerful, is that line between these libraries going to start to blur? Or are we just going to need even more specialized tools in our data science toolbox? It's a fast-moving world, that's for sure. It's an amazing time to be a part of it. So keep learning and keep building.